In this video, we will be investigating power series and finding the values of x for which this power series converges. So let's define what exactly is a power series. If x is a variable, then an infinite series in this form is called the power series. More generally, an infinite series in this form is called a power series centered at C, where C is a constant. So just to tell you, in this form, it would say that the power series is centered at 0. And you can tell if C is equal to 0, you would just get the x values. Because we are using x as our variable, we can write this power series as a function of x. The domain of f is the set of all x for which the power series converges, and that is our primary concern of this video. Of course, every power series converges at its center because if you come back here and substitute in x is equal to c, you would of course get that series where all of those terms are 0 and our function would converge at that value. So c, whether it's 0 or some other constant, is always part of our domain, and so at the very least our domain is a single point. But what else can happen? Our domain can be, of course, our single point of c. It can also be an interval that is centered at c. It can also possibly be all real numbers. Our job today is to find out exactly what case we have. And so from there, we have this theorem that says, first of all, we're going to call R the radius of convergence. And so if we have a power series centered at C, and R is the radius of convergence, then the series converges at x is equal to c, and our domain is only that. The series converges absolutely for when this is less than the radius of convergence and diverges everywhere else. In that particular case, it is sometimes less than or equal to, sometimes not. You will always have to check the endpoints to know whether or not you include those endpoints or not. And then, of course, the third possibility is that the series always converges and our domain is all real numbers. So you're going to be faced with finding the interval of convergence for each series. In other words, when will this power series converge? So you notice I've taken and tried to write out the first few terms so you can kind of get the idea of what you're looking at. So x, again, is a variable. Our job is to find out what values of x will make this converge. Let's investigate the graph of this infinite series. When will this power series converge? The following animation will display these graphs, and as you watch it, see how these graphs converge between the values of -1 and +1. Here I am replaying the animation and letting n go from 1 to 100. The blue box in the middle is trying to emphasize how much those graphs are staying pretty much the same between the values of -1 and +1. But now let's look at the values when x equals to 1. Are those values converging? No. In fact, as n is getting bigger, the value at x equals to 1 is unbounded. It just increases and increases. But what about when x is -1? Is it converging to a value? As n gets larger and larger and larger, that value is getting pretty much almost the same. In fact, right there it seems to stop. but n is still increasing. So you can see that these graphs converge somewhere between -1 and +1, and it looks like that it would include -1 but does not include +1. Now, how are we going to show that with calculus? So how do we go about finding the interval of convergence? Well, let's use what's called the ratio test. Recall, the ratio test will converge if the absolute value of this ratio is less than 1. So that's what we're going to do. We're going to take the limit as n approaches infinity of the ratio of x to the n plus 1 divided by the square root of n plus 1 divided by this. And remember, when we divided, we just multiplied by that reciprocal. What happens? Well, I can reduce this, and this would be left with x. And so then I could say the limit as n approaches infinity of x times the square root of n over the square root of n plus 1. What happens here as n approaches infinity? Well, again, we have the same degree over the same degree, leading coefficients, so this is going to reach a limit of 1. So this is going to be the absolute value of x. And you're going, well, that didn't tell me anything. Yes, but this did. Remember, this will converge if that ratio is less than 1. So right there, our radius of convergence is 1. In other words, this absolute value, remember, when we remove the absolute value, it means it's between the positive and negative value of that given number. Now the question is how do we arrive at knowing that we would include -1, but we don't include +1? That's the tricky part. So we have to check the endpoints. So we're going to let x equal to -1. So we're going to go back to our series and let x equal to -1. So we're going to have this series, -1 to the nth power over the square root of n. And the question is, does that converge or diverge? What test could I use? Well, because this is negative being raised to a power, I know that's an alternating series, so I think I'll use the alternating series test. So the first thing of that is to see if the limit of the nth term, does that equal to 0? Yes, it does. And the second part of the alternating series is to show that it decreases. So is the n plus 1 term less than or equal to the nth term? And yes, that is true as well, because we have a bigger denominator, so we have a smaller term. So we would say, yes, this converges by the alternating series test. So when x is equal to -1, this series converges, and so that's why I need to include -1. Now we have to let x equal to +1. So where there was an x, we put in a 1. Well, 1 to any power is just 1. And that's the same as 1 over n to the half power. You should recognize this as a p-series, where p equals 1/2. Since that's less than 1, that diverges. And so that's why we are not going to include +1. So our domain at which this series converges is -1 to +1, and it includes -1, which we clearly saw in the graphical animation. So you can write your answer like this, or you can write it in interval notation with the brackets and the parentheses. Either way is okay.